Hello and welcome to Physics Trek. I'm Alan J, here with another work solution to help you improve your physics and to show you best practice in answering questions. So let's get started. Success in solving any problem concerning an object falling under gravity depends on a thorough understanding of a simple sign convention. And the sign convention is simply that the initial direction of motion is positive. So if an object is thrown upwards, upwards is the positive direction. If an object is thrown downwards, or simply allowed to fall under gravity, then down is positive. This convention gives us two sets of equations of motion, one for upwards motion and the other for downwards motion. These diagrams will help you understand. First, let's look at something familiar. The original velocity u is positive, so motion is measured positive to the right. Final velocity v and acceleration a are both directed to the right. The time t takes the direction of elapsed time from start to finish. In physics, this is called the arrow of time. And we have our familiar equations in terms of these quantities. V equals u plus at, v squared minus u squared equals 2as, s equals ut plus a half at squared. Now when we rotate the diagram 90 degrees clockwise, everything is the same. Well, almost. U and v are directed downwards and the object is accelerating downwards, but in this case the object is accelerating at g meters per second. So in our three equations, acceleration a is simply replaced by g, and the equations change to v equals u plus gt, v squared minus u squared equals 2gs, s equals ut plus a half gt squared. Now if we move our diagram through 180 degrees and consider the object being projected upwards, u and v are both positive as before, but g is in the opposite direction and therefore negative. It is called the deceleration or retardation in this case. Now let's see how this changes the equations of motion when we replace a by minus g. We get v equals u plus brackets minus g close brackets t, giving v is equal to u minus gt. We have v squared minus u squared is equal to 2 bracket minus g close bracket s, giving v squared minus u squared equals minus 2gs, multiplying both sides by minus 1. This gives us u squared minus v squared equals 2gs, and our third equation is s is equal to ut plus a half in open bracket minus g close bracket t squared, which gives s is equal to ut minus a half gt squared. So for each question in this series, just to remind you, we'll have these two sets of equations by the side of the page, one set for upward motion and the other for downward motion. So let's move on. Here is our question. Question 1. A stone is thrown vertically upwards with an initial velocity of 14 meters per second. Find 1. The maximum height reached, 2. The time taken before it reaches the ground. Down the side here are our sets of reference equations, and writing out the information given in the question in symbol form, we have g equals 9.8 meters per second, u equals 14 meters per second, v equals 0 meters per second. The maximum height reached is s, the time to reach maximum height is t, the required time to go up, reach maximum height, then come down to the ground is 2t. The stone is thrown vertically upwards, so we use the second set of equations. We need s and have u, v and g, so we use u squared minus v squared equals 2gs. So making s the subject, we first turn the equation around, then divide both sides by 2g, leaving s on its own on the left. So s is equal to u squared minus v squared all divided by 2g. Now putting the numbers in. S is equal to 14 squared minus 0 squared divided by 2 times 9.8, which is equal to 14 squared divided by 19.6, which gives us the answer of 10 meters. Now to the second part. We need to find the time t, that's the time to the maximum height. We have u, v and g, so obviously we use v equals u minus gt. Taking gt to the left and v to the right and changing their sign, we get gt is equal to u minus v. Dividing both sides by g, we get t is equal to u minus v all divided by g. Putting the numbers in, t is equal to 14 minus 0 all divided by 9.8. 14 divided by 9.8 gives us 1.43 seconds. Therefore, 2t, which is what we want, is equal to 2 times 1.43, which gives us 2.86 seconds. So we have our answer summary. Okay, part 1. Maximum height reached is 10 meters. Part 2. Time to reach ground is 2.86 seconds. And that's all for now. I hope this video has helped you out. Do look out for other worked solutions on the topic accelerated motion under gravity. More coming soon. Anyway, thank you all for watching. Please do subscribe to the channel and be the first to see all the latest releases.